Hi, this instructional video is about solving rational equations. Solving rational equations. Let me show you number one. You notice there's three different denominators here. Three different denominators. The question is, what are they? Well, we have x plus 3, we have a 5, and we have something that we can simplify. So let me go ahead and do that. Between 3x and a 9, common factor is a 3. So if I go backwards, I get 3 times x is 3x. 3 times 3 is 9. So let me rewrite that. So we get 10 over x plus 3 minus 3 over 5 is equal to 10x plus 1 over the factor form, 3 times the quantity of x plus 3. Now how many different denominators do you see? I still see 3. Here's how I see it. Draw the parentheses over the entire equation. What I see is the 3, the 5, and x plus 3. Those are the three different denominators. What do I do with that? I take the entire denominator set and I'm going to distribute it to each of the quotient inside the parentheses, the entire equation that is. And here's what happens. The x plus 3 simplifies the x plus 3 here. They cancel out. Boom, boom. What remains outside quotient is 3 times 5 times the 10. So 3 times 5 is 15 times the 10 is 15 with a 0. Minus, now take the entire collection of denominators again and multiply to the second quotient. And what happens now is the 5 cancels out the 5. They simplify. They reduce to a 1. So what remains is now just 3 times this 3 times the binomial x plus 3. So 3 times 3 is 9 times the x plus 3, which we will evaluate a little later on. And finally, when you take the entire collection of the denominators and multiply to a third quotient, the 3, they cancel, or they reduce to a 1. The x plus 3's, they reduce. What remains is just a 5 times a 10 x plus 1. 5 times 10x plus the 1. Look at that. And by doing so, all the denominator is gone. And we go back to the beginning of the Algebra 1 course, which we talked about distributive property, combined like terms, and solving for the equation that have variables on each side of the equation. So let's go and evaluate. We have 150 minus 9 times x is 9x. Negative 9 times 3 is negative 27. On the right side, 5 times 10x is 50x. 5 times 1 is 5. And let's go and combine the like term. 150 minus 27. That gives me 123 minus the 9x. And let's put everything together. Here's how I do it. Here's an x on this side. I always like to move the smaller x to go to the bigger x. So in this case, you do the additive inverse. You add 9x to both sides of the equation. And let's do this simultaneously. You have come a long way enough to see this. Here's a 5. Let me get that out of there. Since we brought the x to the right, now let's get rid of the constant and move it to the left. And in doing so, combine all the like terms. Here, the additive inverse cancels out, leaving you with 50x plus 9x is 59x. And what's on the left side? The negative 9 and positive 9 cancels out. And 123 minus 5 is going to be 118, I believe, huh? And now how do you solve for x? You divide the coefficient 59 to both sides of the equation, and something cool happens. 59 goes into 118. Boom! 2 times. Now why don't you try number 2? So if you said, hey, I like what you did over here, just identify all the different denominators. So I'll start right here. Draw the parentheses over the entire equation. And I see that there's 2 different denominators. I have x plus 7 and x plus 2. Now you take the collection of all the denominators and you're going to distribute it to each of the quotient inside the parentheses. You're going to distribute to each of the quotient of the equation, that is. So when you take the entire collection and multiply to the first quotient, the x plus 7 reduces out, cancels out the x plus 7 here. So what do I have remaining? It's just x plus 2 times the numerator negative 3. So negative 3 times x plus 2. And that equals, when you take the entire collection and multiply to the second, this time the x plus 2's cancel out, leaving you with 2 times x plus 7. Once again, no more denominator. Now let's evaluate. Do the distributive property, so we get negative 3x, negative 6 equals 2x on the right plus 14. And once again, you noticed, hey, negative 3x is smaller, so let's move that. And at the same time, you're thinking, I could do this simultaneously. Since we move the x's to the right side, let's take all the constants and take it to the left by doing its additive inverse. So minus 14. So as a result, the 14's cancel out from the right, leaving you with just 2x plus 3x, 5x. On the left side, the negative 3x and positive 3x, they cancel out, leaving you with negative 20. Isn't it nice how things work out so cool like this? And how you get rid of the 5? Well, take that and divide to both sides of the equation, and you end up with x is equal to negative 4. So, if you got that, why don't you try numbers 2 and 3. 3 and 4. Maybe I should do this one for you. Okay, so how many denominators do I see? It appears to be just 2, but there's something more hidden over here, because by this time you know how to factor trinomials, and you realize that this trinomial is a multiple of two binomials made out of x and x. 4 times 6 maybe? And if the bigger number is negative, wouldn't that give me a negative 2 in the middle? And the multiple of 4 and negative 6 is negative 24? Yep. So let me rewrite that to make it a little organized. So we have a binomial, the factor form x plus 4 times x minus 6. Now how many denominators do you see? I see 2 different ones. So now you draw the parentheses, and you're going to list all the collection of the denominators to one side of the equation, and you're going to distribute them. So if I take the entire collection and distribute to the first quotient, the x plus 4's cancel out. Boom, boom. What remains is the numerator 8 times the remaining binomial x minus 6. And we're going to evaluate that a little later on. Now you take that and set it to the In this case, nothing cancels. Nothing reduces for the denominator, so you have no choice but to multiply the entire thing to 1. But you know what? Let's go ahead and re-evaluate that into a trinomial, because we're going to combine the like terms anyway. So let's make that as x squared minus 2x minus 24. Okay? And that equals, well, to the third one, whoa, everything cancels. X plus 4, sayonara. X minus 6, x minus 6. I guess in German you could say choose. So all you have remaining is 5x. Combine all the like terms. Let's evaluate this guy. That's going to be 8x minus 48 plus x squared minus 2x minus 24 equals 5x. To combine, we get 8x and minus 2x. So we get x squared plus 6x. The constants, negative 48 and negative 24, gives me minus, what's that, 72? Quick. Is equal to 5x. I see what this is going to happen here. we're going to get a quadratic equation. Bring the 5x over. So we have finally x squared plus 1x minus the 72 is equal to 0. Is that the answer? No. We're looking for x. Let's see if you could see that first of all on the camera. Yep, you can still see it. So if I factor this trinomial, we get x and x. 8 times 9 is 72. And if the bigger numbers are positive, it'll give me a positive 1 in the middle. And the negative 8 times positive 9 is negative 72, the C term. So my zero product property, if I solve it for each, if I add 8, x is going to equal positive 8. Or x is going to equal, when I subtract the 9, minus 9. So those are my two solutions that will make my equation true. Okay? Now you try that one. Alright, so you said, let's factor this guy first. And you probably have a premonition that it is these two binomials multiplied to get this trinomial, and you would be correct. Okay, a quick visual. 3 times 7 is positive 21. 3 plus 7 is 10x in the middle, so we good. So you ask yourself, well, what are all the denominators we see? There's only 2. So let me rewrite this to clean things up a little bit. And you know what? Since we're at it, no, never mind. I was going to factor this guy, but later on, we're going to move it over to one side of the equation anyway. So let's leave it like that. And finally, here we go. So we're going to draw a bracket this time. Let's make it fancy, huh? And say, what are the denominators? They are x plus 3 and x plus 7. Now let's distribute them to each of the quotients inside the bracket. So what happens if you take that collection of the denominators and multiply it to the first quotient, x plus 3 cancels out. Boom, boom. What leaves me is then 2x times the binomial left over, x plus 7. Minus. Take the whole thing and go to the second one. This time, x plus 7 cancels out. So you have x times the remaining binomial, x plus 3. And finally, if you take the collection to the third quotient, the entire denominator and the coefficient cancels out, leaving me x squared minus 1. This is getting good. We're almost there. So now 2x times x is 2x squared. 2x times 7 is going to be 14x. Negative x times x is negative x squared. Negative x times 3 is negative 3x. And that equals what's on the right, x squared minus 1. 2x squared, 1x squared negative. They become just 1x squared. 14x positive, 3x negative becomes 11x positive equals x squared minus 1. Oh, they're the same. So if I bring the x squared over, it's going to cancel out. So I have 11x is equal to negative 1. Divide to negative, my tongue is stuck. We get a quotient, negative 1 over 11. I hope that's correct. For now, I'm going to stop, which you probably cannot see. So x is equal to negative 1 over 11. Is this the answer? Hold on. And I just redid it again, and I've even plugged it in, and it shows negative 1 over 11 is the good answer.